Unit 6, Introduction to Quadratic Functions, Day 29, vertex form. What information can we gather using the vertex form of the quadratic equation? Okay, and so for this video, I'm going to focus on the introduction and launch portion and work through how to identify the changes that happen on a graph when we change different values within the equation. And we're going to use the graphing calculator. So everyone can go ahead and click Desmos graphing calculator and open that up. And you can follow along on your own calculator as we work through these. So the first question says, graph y equals x squared and add different numbers to x before it is squared. And we have two examples. So let's go ahead and do that now. So we're going to graph this parent function. And we're focusing on vertex form. So I want you to notice, what is the vertex of this function? It's that point 0, 0. The vertex is the turning point, or the minimum or maximum. So in this equation, the vertex is 0, 0. Now, if I add 4 inside the parentheses, what happens to the vertex? How does the vertex change? What if I subtract 3 in the parentheses? How does the vertex change here? You might be noticing something interesting about I subtracted 3 and now the vertex is at positive 3. I added 4 and now the vertex is at negative 4. That's something to notice. I'm going to delete this. We can use the slider as well to kind of help us see. As I change that number, if I make it an 8, how does the vertex change? If I make it a negative 8, how does the vertex change? And you can jot down these observations in this space here. I'm going to zoom out once, actually, just so we're counting by ones on here. Oops, there we go. 1, 2, okay. So next it asks you, graph y equals the quantity of x minus 1 all squared, and add different constant terms, and it gives some examples. So let's go in, let's delete this, and let's change this. Okay, so there's the original one they asked us to graph. I'm going to copy that, but I'm going to add a different constant. I'm going to add, they asked you to add 5 and then negative 9. Well, first notice, what's the vertex here? Interesting. Minus 1, positive 1. Interesting. And then it's saying add 5. How did it change? How did the vertex change? What if I subtract 9? Maybe you can make an inference. What do you think is going to happen when I subtract 9? It's down there. Let's change the color of this to green. Okay. Interesting. 1, negative 9. 1, 0. 1, 5. What if I change this and add a slider? How does changing that constant term affect the vertex? Okay, and you can go ahead and jot down those observations here. The last one is asking you to multiply by different coefficients, 3 or negative 2, and notice how that changes the vertex. So let's look at the original. We know that original vertex is 1, 0. Let's multiply by 3. Well, it got skinnier. Did that change the vertex? Interesting. What if I do negative 2? It flipped. It got thinner. But look, same vertex. 1, 0. They're all intersecting at that same point. So let's use the slider and just play around with it. What happens if I change that term outside? I know from previous lessons this makes sense, right? It gets narrower, it gets wider when we get between 0 and 1. It flips in the negatives, the actual graph, but does the vertex change? Interesting. Okay, so then you can go ahead and jot down your observations here. So because this lesson is focusing on vertex form, we can really focus our observations on how the vertex of the graph changes when we adjust these values within the equation. You can also ask yourself, where might I find the vertex in the equation? Why is this called vertex form of an equation? Now, you are then going to be able to use the inferences and the observations you made here to answer these explore questions. You can answer this. What are the coordinates? What do you think the coordinates of the vertex are going to be here? Compare it to the y equals x squared graph. How did it change? Think back to the launch, and then you're going to answer, does the graph open up or down? And you should know from the from the last portion we just did, what makes a graph open up or down? What part of the equation tells you if it's an upward facing U or an upside down U? And you'll answer this, and then you'll go ahead and fill in, check these on your calculator and check if your predictions were correct. Okay, so in summary, when looking at an equation of a quadratic equation in vertex form, we can pull key information out about what the graph would look like without even seeing the graph.